Good morning to all and welcome back to the online teaching for the session 2020-21. I am Mrs. Savi Joseph, your physics teacher. Let us continue with the same chapter, motion. The previous modules we had seen the equations of motion and its derivation. I hope all of you understood the topics. Today we will discuss about the graphical representation of motion. All of you know what is a graph and what is its advantage. The pictorial representation of data is called a graph, and there are different types of graphs like a pictograph, bar graph, histograph, pie chart, etc. And the advantage of representing the data in the form of a graph is it is easy to understand and we can draw the conclusion very easily. Here we will discuss the various type of graphs which can be used to calculate speed or velocity, acceleration and distance travelled by a body. A very important point to remember here is that in the drawing of graphs, the terms speed and velocity are used in the same sense. In most of the graphs which we are going to discuss now, we will be using the term speed. At some of the places, however, the term velocity will also be used. We will first study the distance time graph. A distance time graph means on the x-axis we will take the time, whereas distance is taken along the y-axis. When a body moves with uniform speed, it will travel equal distances in equal intervals of time. In other words, the distance travelled is directly proportional to time. Thus, for uniform speed, a graph of distance travelled against time will be a straight line. That is, the distance time graph of a body moving at uniform speed is always a straight line. In other words, a straight line graph between the distance and time tells us that the body is moving with uniform speed. The slope of a distance time graph indicates speed of the body. So, the distance time graph of a body can be used to calculate the speed of the body. To find the speed from the distance time graph of a body, we take any point A on the straight line graph and draw a perpendicular AB on the time axis. This is the time axis. It is clear that AB represents the distance travelled by the body in the time interval represented by OB. We know that speed is equal to distance travelled upon time taken. Now, the distance travelled is OC, which is equal to AB, and the time taken is OB. So, putting distance is equal to AB and time is equal to OB, in this equation, we will get speed is equal to AB upon OB. But AB upon OB is known as the slope of the graph OA. Therefore, in the distance time graph for uniform speed, the speed of the body is given by the slope of the graph. In other words, the slope of a distance time graph indicates speed. If the speed of a body is non-uniform, then the graph between the distance travelled and time is a curved line. It is also called a parabola. So we can conclude, if the distance time graph of a body is a straight line, then its speed is uniform, and if the distance time graph of a body is a curved line, then its speed is non-uniform. We will now discuss the speed time graphs of a moving body. In fact, the speed time graphs are also known as velocity time graphs. We can have three types of speed time graphs for a moving body. These three cases are when the speed of the body remains constant. If the speed remains constant, there is no acceleration. Second case, when the speed of the body changes at a uniform rate, then there is uniform acceleration. And the third case, when the speed of the body changes in a non-uniform way, there is no uniform acceleration. We will see these three cases one by one. First case, speed time graph when the speed remains constant. If the speed time graph of a body is a straight line parallel to the time axis, then the speed of the body is constant as shown in the figure. Since the speed of the body is constant or uniform, there is no acceleration. We can find the distance travelled by the body in a given time from such a speed time graph. In a speed time graph, the area enclosed by the speed time curve and the time axis gives us the distance travelled by the body. The distance travelled by the body in a given time for such a speed time graph is distance travelled is equal to speed into time. Here time is on the x-axis and the speed or velocity is marked on the y-axis. So the distance travelled will be equal to the area of the rectangle OABC. Second case, the speed time graph when speed changes at a uniform rate. When a body moves with uniform acceleration, its speed changes by equal amounts in equal intervals of time. In other words, the speed becomes directly proportional to time. Thus, the speed time graph for a uniformly changing speed will be a straight line. We can find out the value of acceleration from the speed time graph of a moving body. To calculate the acceleration at a time corresponding to the point Q, we draw a perpendicular QP from a point Q which touches the straight line graph at point P. We know that acceleration is equal to change in speed upon time taken. Here the change in speed is represented by PQ, whereas time taken is equal to OQ. Therefore acceleration is equal to PQ upon OQ. But PQ upon OQ is the slope of that speed time graph OP. Therefore, we conclude that in a speed time graph, the acceleration is given by the slope of the graph. The distance travelled by a moving body in a given time can also be calculated from its speed time graph. The distance travelled by the body in the time corresponding to point Q will be equal to the area of the triangle OPQ, which is equal to half the area of rectangle ORPQ, that is equal to half into area of rectangle ORPQ. Therefore, the distance travelled is equal to area of triangle OPQ is equal to half into OR into OQ. Next, we will see the speed time graph when the initial speed of the body is not 0. This figure shows the speed time graph of a body having an initial speed equal to OB and then accelerating from B to C. In order to calculate the value of acceleration from such a graph, we will have to subtract the initial speed OB from the final speed AC and then divide it by the time OA. Thus, the distance travelled by the body in this case is equal to the area of the trapezium OBCA. You know that the area of a trapezium is equal to half of the sum of two parallel sides into height. Here the parallel sides are OB and AC and the perpendicular distance is OA. Therefore, the distance travelled is equal to OB plus AC into OA divided by 2. In a speed time graph of a body, a straight line sloping downward indicates uniform retardation because here the velocity is decreasing. Now we will discuss about the speed time graph when speed changes at a non-uniform rate. When the speed of a body changes in an irregular manner, then the speed time graph of a body is a curved line. That is all for today. I will see you with a new topic in the next module. Till then, thank you, bye bye and take care.